Okay. Well, hello everyone. Name is Mauricio Cano. After a very nice talk by Sebastian, we will have a bit of a break, I will say. There's a lot of information I'm going to dump, but the slides will be shared, so the content will be there, and I have a blog, so you can also follow that later. So first of all, well, my name is Mauricio. I have a PhD in computer science from the University of Groningen. I have been working on Deloitte for 3 years as a penetration tester for cloud and cloud native infrastructure. I focus on Azure, containers technology, Kubernetes, these kind of things. And yeah, I'm in love with container technology. I like the idea of hacking at such a low level because it becomes quite a low level. And that's a little bit what I would like to share today. So we're going to talk a little bit about containers, as I mentioned. So that's going to be a little bit of a info dump on that. And then we will mention a little bit about container escapes and what does a container escape means, at least in the penetration testing world, so to speak. We will talk a little bit about patterns, and then we will talk a little bit about why tools like SAST and DAST or container scanners are sometimes not enough to actually ensure security because they are easily bypassable by doing certain things. Why is learning about containers useful? Well, usually you will hear about containers now everywhere. If you go to cloud or if you go to any kind of application, even certain type of internal clouds, they all are running on OpenShift, Kubernetes, Nomad, whatever kind of container orchestration tool you might imagine, even Docker Swarm or Docker Compose to some extent. Most web applications have now been containerized, so that means that basically you have a container that is running your web application, and that is what you're pen testing if you're a pen tester. So it's pretty interesting when you find something that you think might be a high vulnerability, and then you get into, I'm still in a jail, so what do I do now? That changes a little bit the perspective from the pen tester point of view and also from the engineering point of view, because you need to think about different kind of security issues. And in general, well, the question that follows is, once you find a vulnerability, what do you do after? Because at the end of the day, yes, most pen tests kind of function as a sort of vulnerability scan, but what you will really like to do at the end of the day is to actually chain a number of vulnerabilities and to reach whatever goal you may have in mind, be it extracting data or escalating privileges or pivoting around in a network, which is a little bit closer towards adversary simulation or towards red team, if you will call it in some way. So one scenario, for example, as I was mentioning, is something very simple. Suppose you get a shell somewhere. Okay, you have an RCE, you have a reverse shell, you manage to get it. So you have some sort of information. For example, in this case, it already tells you that it's a container, but sometimes it will just tell you, okay, you have some sort of Linux distribution. And then part of the enumeration and part of the things you would like to do at the beginning will be something like check which processes are being run. Containers sometimes look like this. Maybe you have some application running, some Nginx server or some other Node.js kind of process, but not much more, which makes you think, okay, what's going on? Because I don't see any processes. What's happening? Most computers have processes. And then that's a big hint you're in a container. So then the question is, what do you do next? So there are a lot of things you can do. You can follow the traditional path that any pen tester will follow, which is try to pivot around the network, try to get some scanners inside, maybe put a beacon if you're really wanted to be extremely stealthy, or try to find some sort of process injection kind of thing to actually try to run your own things through memory instead of writing on disk. Or you can try to escape out of the container, which implies acting in the host, which I will say is my favorite way to proceed, because that means that all of the containers and all of the applications that are running containers in that particular host are compromised. That's as simple as it gets. Because you are entering into the host of the container, and if you are in an orchestrator, something like a Kubernetes cluster or Nomad or whatever, once you are in the node level, then you can just try to pound the full cluster if you want, which means that you have access to everything that is in the cluster, and from there you can move whatever you want. The first thing to understand is what is a container. And at the end of the day, a container is just a process. It's just a process in Linux and sometimes in Windows to some extent that is isolated via some sort of structures. In the case of Linux, it's going to be cgroups and namespaces. And I'm going to explain a little bit how that looks. So if you run a container in a computer and you, let's say, first run a PS, you don't have anything there. If you run a container, something like an Nginx container, for example, from Docker, you will find some processes running in there. And these processes will have some parent IDs and child's IDs and the whole forest kind of thing. What's interesting is that at the end of the day, the container will just be a file somewhere in the host. And that particular somewhere is going to be the proc file system, which is all the Linux processes are hosted there. And in the proc file system, well, you have some sort of PID, and that's going to give you your container space. So in this case, you can see here a bunch of PIDs or process IDs. And the thing you need to remember is one is root. So everything you can do with root, you can do under one. And all the other ones are different kind of processes. You will like to find the one for your container. And then you will find things like, for example, if you see the proc file system, you see then the PID of the container, and you go to root, you will see what is on the root of the container. So if you create a file in there, you will have a file inside the container. Because it's being mounted. It's basically just mounted the cgroups and the namespace of the actual container. And again, this is just an example of how it goes, how it looks. So you can create your file and you will see it inside your container, which is a difficult thing. I will move a little bit to the demo in a bit because I think it makes more sense. Things that might be interesting to keep in mind. All the environments variables are usually in the environ part of the proc file system. It really depends. So if you ever run into a container, a very common thing that we engineers do all the time is put secrets as environment variables, which makes a lot of sense. They usually can be found there. So if you, for example, can download manifest from a Kubernetes container because you have read-only access, you will be able to see all the environment variables. If you get read-only access to an AWS account that has, for example, ECS containers, you will be able to read all the environment variables, which means you will be able to read all the secrets. Again, the entry point and this kind of things is just a part of what is in there. Now, how isolation happens in Linux, because Windows has its own kind of structures and processes to do that, is all about cgroups and namespaces. So cgroups, or control groups, as the name of the Linux, were introduced by Google in 2007 or so. And what they do is basically allow to control resources in the container. So you give it access to certain resources. And the namespace, what it will do is to isolate or to allow the container to see only certain things. So there are several namespaces. Unix timeshare system, which is the UTS namespace, process IDs, which is important, mount points, which is also important because you see mounts from the actual Linux system, the network namespace, users and group IDs, which allow you to belong to a certain user or to a certain group. And that is also important because if you have follow trains in containers, what you will find is the whole idea of rootless containers or user namespace containers where you are not root. And that's something that I will explain in a bit. The IPC namespace, which is kind of low level and is about shared memory. You can do some interesting things with it, but we won't go too much into that. And of course, the control group of the control groups, which is the control group that allows you to control control groups. Kind of a thing here. Now, as I was mentioning, something interesting is the user namespace, because most containers still are user or still live within the user from the Linux system. So if you are root in the container, most of the time you are also root or in the same namespace as root from the host. Now, you might be isolated because you don't have as many capabilities, which is a type of isolation that containers have, but you're still root. So if you manage to get out of the container, you will be root in the host. And that is something important to consider, because many containers by default give you root. PID namespace, as I mentioned, if you have access to the PID or to the process IDs, then you can actually just have access to all the processes running in the container, which is a bit of a problem if you think about it. And then we heard a lot about don't run privileged containers. But what is a privileged container? So in general terms, a privileged container is just a container with a lot of capabilities. It doesn't even matter. It doesn't even have to have the privilege flag. The privilege flag, the only thing that does is to add a lot of capabilities to it, and in particular the sysadmin capability, which is the greatest capability you can have within a container, which basically lets you do anything in the host. Now, most escapes are playing with capabilities. So if you have sysadmin capabilities, or if you have chroot capabilities, or if you have chown capabilities, or combinations of different capabilities which will allow you to execute certain system calls or kernel functions, then you will be able to escape. Again, the first breakout that I'm going to show, and I'm going to try to demo them all, but let's see if time works, is using the release agent. The release agent is a nifty little feature that basically whenever a C group is released or a process is released, there is something called a release agent which executes with the highest possible permissions within the container. And that's something that will basically execute as root if you are rooting the host, as I mentioned. So you will be able to execute any kind of action inside the host from the container itself. One note on that is the reason why I'm showing this is because we always hear about the dangers of certain containers, capabilities and stuff, but it is not often that we see how to actually exploit them. And kind of that is the idea of this presentation, to show how this works. We have this small Kubernetes cluster here in, wait, is this one? Here in GCP, so it's Google Cloud. We have a few pods here that I have created. The first thing to do is, and this is going to be interesting, so I'm going to put the microphone here, and I hope that it doesn't sound. Do you hear me well if I speak like this? Okay, cool. Let me give you a hand. Literally. Thank you. So basically, the thing that we will do here is just to exec into the container. And in this case, it's going to be called the release agent container. The command. Once we're here, then the next thing that we need to do is basically just to mount a C group, because we're talking about C groups, and to mount a child. So what we'll do is simply just make a directory. So that's the mkdir -p that is called hack C group. Mount the C group because we have access to the mount command. In this case, we're mounting the RDMA C group, and then we are going just to create a child within that C group, which is named X. The file already exists because I did it before, so I have to improvise. Probably what I can do is just, let's just do this. It's already mounted. Sure. Okay. Nice. So demos. I need to change all the names. That should be enough. Yeah. So it creates that particular file over there and it mounts it, so it will look like this. There we go. And then you have a bunch of things over there, which is what's going to be contained in the C group. What is important is the release agent. That's what we want to change. So in this particular case, the next step is to allow the release agent or the notify on release, which is going to be over here. And we do it on the one that we created new, which is 1. And then after that, what we would like to do is just to find the path of where the host is mounted. Now that's a bit of a mouthful, but the host itself will have a mount point within the container. Usually you can do it with mtap, but because I am in Google Cloud and I'm using containerd, it doesn't really mount the mtat file. So I can do it just using proc and mounts, which will give me the same thing, which is what I do here. And if I print this variable, then it's going to give me the path of the actual mounted container, the overlay file system, basically. Once I have the overlay file system, then the next thing is just to create the command or to give what's going to be the command. In this case, we want to just put it in the release agent of cgroup1. That's going to be just an echo inside that file. Then what we do is to create the command. In this case, I want to do ps aux because it makes things a little bit simpler. And what we do here is just okay. We're basically just creating this output one file, just to call it somehow, and we put it inside the CMD. After that, then the next thing is just to give it permissions, of course, because we need to allow it to execute, otherwise it won't work. And once we have done that, the only thing we need to do is to basically call any process that will call the release agent afterwards. And then after that, I should have this output one file here. Now, if we read that file, then it's going to be all the processes inside the actual host, which means you are executing commands inside the host, which is what we wanted. That is one pattern of escape that will let you, for example, do a reverse shell from the host or do this kind of things. After that, well, as I was mentioning, this is what you will get. There are other patterns. I think there's only one that I want to show because it's interesting, which is the core pattern. Basically, whenever you have a core dump exception in the host, you will get the script to execute. And then we can probably go with that one just to not bombard everyone with things. But in the meantime, are there any questions about what I've shown so far? No? Okay. Then the first thing is we move to a new pod because I prefer doing this in a new pod. And then same pattern. As you can see, these pods are by default root, and I didn't even do anything about it. It's just the nginx container. The first thing we can do, for example, is to verify that we have the file that we want. And the file that we want is called proxys kernel core pattern. It's basically the pattern that will be executed whenever there is a core dump in the system. Same kind of behavior. We find the host path. That's a critical part. And sometimes you can do it this way. Sometimes you don't have these files because the containers are properly secure, which means that you need to try more creative things. Then same pattern. We just create a command. And the command will contain certain things. In this case, okay, let's do something different than ps aux because that's boring. Yeah, okay. It's probably one that is the best example to show. Same thing. We just give the command permissions and this is the new part. So basically we just write into the file system what is going to be executed afterwards. It has to be preceded by a pipe. That is just the syntax of that particular file. And then we just run a small fork bomb. And it will take some time. But it should just core dump at some point, and then the new file will be created because the core dump exception allows you to create these kind of files. So what I'm showing here is basically just one way of doing it. It's one of the easy ways. Of course, there are more complicated ways to do it. We have the core dump here, so we can do ls, and then we have the output file again. And it's the same thing. I'm just getting all the processes from the host. There are other ways, and thinking about this kind of escapes is kind of the first step into thinking about, for example, how to escape out of VMs at some point, because we're thinking of different types of isolation and how it works. So KVN, for example, or using devices, all those kind of techniques, trying to use drivers, for example, kind of will apply to some extent in here. There are, again, different types. If you want to be a bit more silent, there is the bin FMT kind of escape pattern, which basically what it does is whenever a certain type, you can configure it in such a way that whenever a certain type of script is run in the host, then the execution will come to the container. So it can be more stealthy in the sense that you can basically time it with whatever other cron jobs or whatever other services are in the host, and then it will work. It has a lot of configurations and stuff, that particular file, but it's the same kind of pattern, and that's kind of the thing that I want to kind of drill into a little bit. It's just that you can generalize the type of container escapes. Now, these container escapes are generalized specifically in Linux because there are certain ways to execute different kind of programs or commands. And the general steps to this kind of thing is basically, okay, you need to find the container file system inside the host, which usually can be seen via mount if you have a container with sysadmin capabilities. Or if you don't have access to that, you can try things like PID bashing or some other techniques which tend to be a little bit more involved in that regard. Now, then you need to find the functionality where you can indicate a script that will be running the host. That usually is some sort of helper function from the Linux kernel or from Linux in general because they contain them. And then one requirement, of course, is that you have enough capabilities to do this, or that you somehow extend your capabilities to do it. There are, again, several things you can do here. Some other things we can think of in this kind of line of thought is using, for example, eBPF, which is something very new, which allows you to communicate directly with the kernel, and some containers may have BPF capabilities, which allows you once again to explicitly communicate via the kernel, and that's kind of a direct escape. But then you will need to understand a little bit how BPF works, which is kind of a little bit like writing a bit of assembly, if you will, or something a little bit more low level. Now, that was on containers. I know that I dumped a lot of information, so I will try to make the slides available because otherwise it's going to kind of just float around. The next thing is SAST and DAST tools and compliance in general. So it's really good to have this kind of tools. But there was a very nice talk in KubeCon this year by Ian Coldwater, Brad Kesseman, and a lot of other people, which basically goes around the fact that compliance usually is not enough. And the reason why it is not enough is because there is a human component which can affect these kind of things. So usually, if you think about how a container scanner or how a general SAST works, is just by pattern matching or by doing certain types of extrapolations into syntactic patterns of the actual files. Or in the case of a container, they do it by scanning certain files inside the container or the layers of the container. For example, if you have an Ubuntu image or a Debian image, they will try to scan the dpkg file, which contains all the dependencies. Now, what happens there, which is another interesting thing, is the following. So I'm going to create another terminal here. I know you cannot see this one, but that's all right. I just want to copy the command. So we have 3D, which is one container scanner of many. It does the scans in a certain way, so I can just run this, for example, and I'm just running the scan on a Nginx image. It will take some time, but it will then show you a bunch of vulnerabilities. Because again, container images usually do not have that many SBOMs, or they have a lot of dependencies which do not even make sense to have in there, which is why new kind of images have come up, like distroless images, Wolfie images, and all these kind of things that companies like ChainGuard, for example, are doing. And then you see a lot of things here. I have also then created a small image or a small Docker file here. That the only thing that it does is to run one command, which is rm var lib the pkg status. That's the only thing that I'm doing. And this kind of passes if, for example, your peer review processes are not good enough and whatnot. And then you try, for example, to run Trivi on that particular image, which is called in my case nginx deleted the pkg. Okay. And it will show several vulnerabilities. And that happens with a lot of different container scanners or static scanners. Even with, for example, dependency scanners, like, things like Bandit for Python, for example. Because they will scan things like requirements files or cargo doc log files or Maven files or the Node.js requirements files. And if those files do not exist, then there's no way of knowing what is happening there. So that is one of the considerations that is important for compliance. And I think that one of the things that needs to happen is that we do need to keep reinforcing that the human aspect of security is really important, because these kind of things should not pass peer reviews. And these kind of things should somehow be checked by a human, or if you want to automate it even more, then by smarter pattern check-ins in the actual code that is being written. That is, again, me kind of pushing through the talk in a really fast way. But if there's any questions or anything, then we can show a few of the other patterns if you would like to see, or we can just answer some questions about containers. Kubernetes in general, as I mentioned, this is a cluster that I created, so I usually play with this. It's very cheap. If you create a Google Cloud account, I have 2 VMs and they have been running for like 2-3 weeks, and I have only spent like $100 of the free credits. So you just create a new account and keep creating a new account until they ban your credit card, basically. But yeah, that's what I wanted to share. Again, very fast, going very kind of running a little bit. But if you want more information or anything, feel free to reach out to me. I am on LinkedIn, Mauricio Cano. That's perfectly fine. You will find me. Yeah. And I can give my email offline if somebody needs it. And I just want to give you maybe 20 minutes back for more networking and other kind of activities were also important. So thank you, Priya. Yeah. Yeah, okay. Oh, okay, the question. Yeah, so it was asking about CWPP. I'm not entirely sure what does this, the acronym. Okay, you mean like, yeah, CSPMs and these kind of things. The answer is it depends. So there are ways where you can pick up on processes that are being run inside containers, but by default, they do not. So I'm thinking about technologies like, for example, Falco, which is open source from Sysdig, or things like Twistlock. They will try to pick up a little bit of these patterns, but you need to kind of bake them in or use some open source library that has them in there, because they usually do not pick them on that fastly or that easily. Yeah, it's kind of an art to come up with use cases. Yeah, there are very nice, again, like there are very nice guides on natural language that tell you, yeah, you should not run you should run a read-only file system, you should not run privileged containers, you should drop bulk capabilities, but they don't tell you how to do it, and they don't even tell you what can happen if you don't do it. And it's a bit of a kind of new thing that is happening. Like CISA, for example, the DoD make a really nice guide on how to harden Kubernetes and containers and CI/CD pipelines. You have, of course, Kubebench and all these kind of things which allow you to have a little bit of a view on how things are hardened. Docker Bench, at least from the CIS perspective. I will say that the rule of thumb is the least you can do in the container, the better. So if you can have a container that is read-only file system, a container that is not root at all, a container that cannot escalate privileges, a container that is only doing what it can do, and it doesn't have any weird libraries, then you are on the safe side. But then again, we enter into the problem, what happens if someone actually gets RCE because the application doesn't have a proper input validation, which is, it becomes a bit of an issue again, because even if you have things like write-only file systems, or read-only file systems, I have been playing around, I haven't really done a lot of it, but I have been playing around with loading binaries on memory only, and you can, for example, load them up only from memory without writing anything over there, something that's happening in Docker sometimes. So that's the kind of things that you may expect. I think that the idea here is that there are technologies that allow you to do it, like, for example, Kata containers, Firecracker VMs or micro VMs. But I think they still tend to be more of a niche rather than actual standardized practices, which I think is a bit of a pity because it's where we would like to be. Sure. Any other questions or anything? If not, then I'm going to be a bit of self-promotion, which is never bad. Yeah, wait, I think I need to, how do I do it? Let's do it inside the container, might be better. Okay, that's horrible. Oh, come on. That makes more sense. Let's go to GitHub, or rather, that is my blog, if you're interested. That's my GitHub. I really don't do much, but it's there. And there's one thing that I have done here, which is about metadata endpoints in cloud, basically showing how you can extract cloud credentials from metadata endpoints from GCP, Azure, and AWS, specifically from basically Fargate containers, Azure container instances, and Cloud Run containers, which showed, there are certain things that people do not consider. So that's the self-promotion piece. So, yeah. Yeah, there is one solution from Checkmarks that is called KICS, is Keeping Infrastructure as Code Secure. It also can scan Kubernetes YAMLs, manifest, and definitions. It's actually quite good because, it's checkmarks. And other tools like the Bridge Crew, what is the name again? When the one that Palo Alto uses also has some scanning over there. Yeah, no, but they have the open source scanner, right? I forgot the name. Yeah, Chekhov, yeah, exactly, that's the name.
Do you know if Azure Blueprints kind of offers limiting the capabilities of Docker images?
I do not know specifically for Azure Blueprints, but I do think that you can make it an Azure policy. So perhaps it's something that is already baked in.
Why do you think, in your view, that it's still so difficult to make like a secure setup running containers? For example, even I see companies that want to build Docker images, and setting up something like rootless build is quite difficult. And I mean, containers are not new. So, in your opinion, why is it still so difficult to make like a secure setup to run containers?
I think this is more of a very philosophical question, so I will kind of rant a little bit here, but I think it's a matter of philosophy, right? So at the end of the day, engineering works a lot like, buildings or, civil engineering. We kind of want to do things fast. And we don't think about the consequences of not putting a nail somewhere or not putting a proper foundation somewhere. Now, in civil engineering, that usually ends up in a destroyed building, which, cost a lot of money, so people actually pay more attention to that. But in the case of systems engineering and in the case of computer engineering, usually nothing happens, and that's kind of a bad thing. Usually we are pretty safe. Like, usually you don't really get hacked that easily. It's not that easy to hack someone. We always, as pen testers, say, no, it's really easy. It's really easy to go and hack someone. But in the wild, you hear them every often, but not that much. And I think that's the main point. We don't have enough fear of what can happen if there are securities. And that's why there's always this kind of toggle war between, boards of companies and security teams trying to get budget that they will not give and all these kind of things. It's just a matter of philosophy, in my opinion, but it is a constant battle of, drilling down security. There will be issues. There will be a lot of money lost, but it never materializes. So they're like, it's fine. So that's the kind of things you see in the wild, I will say. Very strong opinion, by the way. So it is more of a personal thing. Any other questions? No, then I think we're done.